Hey everyone, thanks for joining me today. I'm excited to talk to you about some of the work that we're doing in the Azure deployments team and talk to you about or dispel one of the myths that customers have around using Terraform with Azure. And that myth is they feel that they can't do everything that they need to do with Terraform, or there's a lag in functionality between Terraform and Azure. So Azure is ahead of Terraform. We've done some work that will allow you to actually manage those services as soon as they come out, and I'm excited to talk to you about that. But first, let's talk about what we are going to go over today. So we're going to start with an introduction. I'll talk to you about who I am, what team is that I work on. Kind of give you an overview of all of the different areas that we're working on for Terraform, and then dive into the coverage, kind of the meat of it being how you actually are able to manage everything in Azure, and talk about some scenarios and do a whole bunch of demos. And then we'll close out with some roadmap stuff, some things that we're looking at doing in each of the different areas in the future. Most of these things will get done, but we're not making any promises. There may be some that don't end up seeing the light of day, but we do want to share it with you so you know that where we're going with a lot of these things. So, all right, so let's start with talking about who I am, what the team is that I'm working on, and why you should care about that. So I'm on as I mentioned, I'm on the Azure deployments team. The Azure deployments team owns anything to do with deployments in Azure. So think if you are wanting to deploy from the command line or even the portal, our broader team owns that experience. So our goal is to make sure that you can be successful deploying to Azure, whichever tool you choose to actually do deployment, whether you want to use some of the native tools like Bicep and ARM templates, or if you want to use tools like Terraform or Ansible, you can be successful and have a consistent experience across those tools. So we're really excited to ensure that you can be successful. And one of the other things you get from all of these tools being under a single team is consistency. So having the similar properties and experience, no matter which tool you use, is something we're striving to show you. So if you choose to go with Terraform and then you want to switch to Bicep, you should have some similar experiences when you move from one to the other. The other thing that we are part of our team is a sister team, which owns PowerShell and CLI. So not only the declarative tools, but the imperative ones are all part of the same broader team. So that gives you consistency across those imperative tools as well. And we all work really closely together to make sure that you have that consistent experience and the full coverage and everything that you're looking for, and you can be successful. All right, from there, let's jump into kind of a broad look at some of the tools that we're investing in, where we are with those tools, and documentation and a number of other things. And then we'll jump into the services from there. So in order for customers to be successful, they need to have some guidance and some best practices. We understand that and are working very diligently to ensure that you have those resources. The first area that I want to talk about is the Azure Verified Modules. So modules, Terraform modules. The verified modules that we're working on is an effort by our team to ensure that you have good quality modules that you can depend on. So if you've been to, and I'm sure you have, if you use Terraform at all, you've been to the Terraform registry. And if you look for Azure modules in the Terraform registry, there are a number of modules up there. But one of the things that you'll find is that a number of those modules are not kept up to date, or there's overlap between the modules and it's not clear which module you should use. The initiative that we have with verified modules is to ensure that there are high quality modules in the registry that you can depend on, not only being up to date, but being consistent and no breaking changes and a number of things like that. We'll talk about some of that in the demo that I do, but we are really wanting to make sure that you can find modules and use modules that you can be successful with and rely on. The next area is documentation. It's not a shiny, exciting area, but we're doing a lot of work to ensure that you have the documentation you need from a Terraform on Azure perspective. And we're actually pushing the creativity of generating this documentation. So we want to make sure that when you go into your service on Azure and you want to manage that service, that you have the ability to see the Terraform guidance on that as well. And I'll show you that in a demo as well, and show you what we're doing there to kind of push that and get you as much documentation as we can there. And the last thing is, if you're not familiar with a service and configuring it with Terraform specifically, having some examples to get you started is super helpful. We have a repo that we contribute to and we own, and that other Microsoft employees actually contribute to as well, and it's open to the community to contribute to. That is a set of working examples that you can take and use as a starting point for everything from API management to Kubernetes to anything else that you want to use from an Azure perspective. And we're doing some really innovative things in there, or some things in there to help you know that those examples are something that you can use in your environment. So, all right, with that, let's jump into a demo here and show you what we're doing in these three areas. So we'll start by looking at the verified modules. So we have this repo, the Terraform Azure Modules repo. This repo is where we have all of our guidance and information about the verified modules. So in here you can find information about what makes, or what verified modules are, what our philosophy is with verified modules, and a starting set of verified modules that we have here. We're working very closely with other teams within Microsoft, as well as our team, to build this list as quickly as possible. But we have a core set of popular modules here that we've onboarded to verified modules. You can see everything from virtual machines to subnets and some of those basic things. We do expect this to grow and grow at a pace and stay high quality. Some of the other things you'll find in this repo are information about how you can contribute. Initially, for verified modules, we are starting with the approach of new verified modules will be implemented by Microsoft employees, and then outside of Microsoft or inside of Microsoft can contribute to those modules. There are some technical limitations we have for actually spinning up the pipelines and whatnot for the verified modules. Once we work through that, we do expect to open it up for the community to actually contribute new modules as well. But for right now, we want you to contribute, and it's limited currently to actually adding features and functionality to existing modules. So this guidance here in Contribute will actually talk about how you can contribute to verified modules and help us actually grow this initiative. Some of the other things you'll see in here are the codex. The codex is a detailed guidance on how you actually author and contribute to verified modules, and you can see everything in here from how you name properties to all of anything in between. So what doesn't show up in here is the pipeline that we have implemented for verified modules. All of these verified modules are onboarded to a pipeline when they become verified modules, and that pipeline tests for consistency in those verified modules. It tests some security things, making sure that properties align to the codecs and things like that. So making sure that we have consistency there. Some of the other things that the pipeline does is ensures that there are no breaking changes. So one of the problems that you can have with modules is version 1.1 of the module will have some properties that you're using. Someone releases 1.2 of the module and completely gets rid of some of those properties, and then you're in a world of hurt and stuck. Our pipeline makes sure that those breaking changes don't exist between minor versions, so you can have that confidence that you can continue to use a module without breaking changes, just like you have with using the verified or the resources themselves. So we're doing a lot of things with these modules to make sure that you can be successful using them. All right, so next I'll jump into the documentation. So for documentation, we are adding a bunch of documentation to this Microsoft documentation sites. You can see here that we have a new section under the quick starts where we have quick starts for Azure services. So we have information about the core Terraform investments over here, like the AzAPI Provider and things like that. But if you want information about how to use Terraform to manage services, you can come here, and there are a whole bunch of different quick starts. This list is growing quickly because of some technology that we are using to do this. So one of the things that you notice here is you're in this example, you're in the Terraform documentation, so the developer hub for Terraform. And you come in here and you can find all of the services that you want to manage here. Again, this list is going to get bigger. But if you click on one of these services, you'll see that you actually go to the service documentation itself, and you can see the Terraform documentation for quick starts along with all of the other CLIs. So that's one of those benefits that I was talking about earlier on with us being all one big happy team. You get consistent documentation across all of the CLIs. So if you're using the API management and you want to use Portal, great, here's the documentation here. If you want to use Terraform, we give you that documentation as well. Some of the things that I mentioned or hinted at that we were doing for documentation in Terraform are highlighted here. We're actually using AI to author these documents. We're not there's a human middleman here, but we're actually starting with AI to generate the documentation based on the examples, and then we update as necessary there. But this is allowing us to really crank these things out. We're averaging, I think it's on the order of 2 or 3 new service documentation from a Terraform perspective every week. So we're really getting these things published, so you'll have more and more documentation here. One of the other things that you'll notice is that we reference the Terraform GitHub here. All of these examples are not hard-coded in the documentation. They are actually in a GitHub repo, and I'll show you that in the next section here. But this documentation will be updated based on changes to the repo itself, so it's not hard-coded into the documentation, which gives you the confidence that when you're looking through this document, it actually works. And there's some other things that we'll talk about in the next section here that gives you additional confidence. But you can see here that you have the good documentation here. We walk you through all of the code from a Terraform perspective and talk you through all of the steps that you need to actually deploy or plan and deploy that configuration, and then verify that that actually was successful. So it gives you a good walkthrough of how to actually use those services. Now let's take a look at these examples here and kind of what we're doing around there that's interesting and exciting. So in we have the Azure Terraform repo here. We have a set of quick starts in this repo. These quick starts actually are the code that is referenced in the documentation. There's more than that. Like every one of these examples doesn't end up being documentation, but they are shared. So you can see in here, there's the API management example here, and we're just looking at the API management documentation. This code that's in here is the exact code that's in the article. So if this code gets updated, the article is reflected of that. So if there are bug fixes to this or what have you, that's automatically reflected in the documentation. So it's great that we don't have to know to update the documentation. If the code works here, it's going to work, or it'll be reflected in the documentation. One of the other things that you'll see here is this test markdown file. We have a pipeline that's similar to the pipeline that we have for the verified modules that runs against all of the examples in the Quick Start documentation, and checks to ensure that that code is functional. So it actually does the deployment in Azure and makes sure that the deployment succeeds. And we'll write the logs here so that you can see not only is this example successful, but you can see what version of Terraform was used to run the configuration and what version of the Azure Ram Provider was used. So you can be confident if you are using this version that this example will work for you. If you're using a different version, you can actually see that we actually track all of the versions that we've run this test against. So you can actually look down and see if you're using an older version of the provider and an older version of Terraform. You can see that that will actually work for you as well. If we have a failure in a configuration, we'll have details about that failure, so you can actually know what actually didn't work there. So some good information about these examples and give you confidence in not only the examples, but the documentation. So we're really excited about this work. All right, so jumping back here, let's move on to some of the other areas that we are investing in from a Terraform perspective. We get a lot of feedback from customers on wanting to actually manage configure or infrastructure that's been deployed outside of Terraform, and we're excited to talk about some tooling that we have. You may or may not be familiar with it. It had a different name previously, but we have a tool that we have implemented to allow you to actually point at infrastructure in Azure and turn that into Terraform. The tool is called Azure Export for Terraform, and it allows you to do just what I mentioned. You can point at a resource group or an individual resource or any selection of resources that you want to turn into Terraform, and it will actually generate the HCL as well as the state so that you can have a starting point for managing that configuration. So a number of different scenarios are enabled by this tool, one of which is you have infrastructure that you want to start managing in Terraform. You can run the tool, generate the HCL and the state. Most of the time you'll need to tweak the HCL a little bit to make it more user-friendly. So you want to add some variables. We have no way of determining what variables you might want to use in there. So you can add variables, you might want to add some looping and those types of things. So you'll want to modify the HCL, but it gives you a really a good jumping off point for actually managing that infrastructure. You don't have to start from scratch. You can actually pull that stuff in and have a really good starting point. The next area is many customers want to, they essentially have a golden state. So they have a good deployment out there that they've done, and they want to replicate that in other areas or other scenarios. You can use this tool to actually generate some HCL that you'll then again want to modify and tweak here and there to actually add those variables and loops and just clean it up so it's easier for you to author going forward. And then you can use that to actually deploy different versions of that infrastructure. And the last one that we have heard that this tool helps out with quite a bit is if there's a new service or feature that is added to Azure and you want to understand how to actually author that in Terraform, you can use this tool to view what the Terraform configuration is and compare that to what you are writing in your separate configuration. So we've had folks tell us that they get stuck. They're trying to use Terraform or the Azure Ram Provider to actually implement Terraform for a new service or feature. They get stuck. They don't know how to do it correctly. So they'll configure it using the portal in the way that they want it to be configured, run the Terraform Export, see what the HCL is that's been dumped out of there, and then actually compare what they're missing in their configuration, update their configuration, and move on from there. It's a really great way of getting unblocked in that regard. So, all right, so some other areas that we are investing in are, we understand that nobody works in a vacuum, and we want to provide ways that you can learn about using Terraform on Azure. So we have been talking to customers. We love talking to customers and getting feedback from customers. One of the things that we found in talking to customers is that many of the problems that customers have, we have solutions for. So we've started doing a regular blog post that highlights all of the work that our team is working on from a Terraform perspective, so that you can subscribe to it, understand what's new, what's out there, what we've done, and know that you can actually use that to solve some of the problems that you're having. We have community calls that we target to have every couple of months or so. The idea there is to have provide similar updates to the blog, but to do it with demos and really help you understand what we're doing, what we're investing in, what's coming, as well as share information from the community. So we want folks that are doing exciting things relating to Terraform on Azure to present in these community calls as well. And we invite you to sign up and present there, or just join and listen in to what's going on. The next thing is we have a Slack channel that we have created for Terraform on Azure community. You can join this. Please do join this and ask your questions about any problems that you're running into. There are a number of folks in the community already, both from Microsoft and from the community, that can help out, that have a ton of experience using Terraform on Azure. So please do join and participate in the community. The last area is, like I mentioned, we love talking to customers. We have a community that we invite you to sign up for. This community is, we send updates out to this community. We invite this community to have calls with us to give us feedback on things that we're thinking about. Just a general way of actually allowing you to participate in the Terraform on Azure future and things like that. So, all right. So next, let's jump into the meat of what we're here to discuss today. So like I mentioned, that one of the biggest pieces of feedback that we get from customers when we talk to you is there's a new service, there's a new feature, there's just not coverage for X in the Azure Ram Provider. How do I do that? I have to fall back to using the CLI in a null resource, which defeats the purpose of actually using Terraform because it doesn't have all of the benefits from a change perspective and all of that. So how do I actually do that? We have heard that for a long time, and we have released a AzAPI Provider, which gives you the ability to actually manage anything on Azure. And we're going to talk about that and kind of show you how easy it is to use and how powerful it is to use. So, before we dive too deep into the AzAPI Provider, I do want to address not the elephant in the room, but talk about the Azure Ram Provider. Just because we've released the AzAPI Provider doesn't mean we're not investing in the Azure Ram Provider. Both Microsoft and HashiCorp are heavily invested in this provider. We both have dedicated engineering teams that invest in this on a regular basis. That's not changing. We are fully focused on making sure that you can actually manage everything in Azure with the Azure Ram Provider. The Azure Ram Provider is a convenience layer, so there will be that delay in getting functionality. We do have a goal to have Azure Ram coverage by GA, and it is a requirement within Microsoft to have that coverage in the Azure Ram Provider. So we are speeding up that delay, or not. That might be backwards, but we're reducing that delay in getting coverage by making it a requirement within Microsoft. So there is a bit of a buffer there, but services that are released are required to not only have coverage for PowerShell and the Azure CLI, but for Terraform as well. So that is a great advantage here, and we are seeing a lot more coverage at an earlier date than we have in the past. So one of the other areas, not every service is required to go through some of these internal processes, but we are finding that the service teams are being contacted by customers like you saying, where's Terraform coverage for PostgreSQL or any other service that is adding new functionality. So the service teams are actually coming to us, and there's a process for them to actually let us know that there's new features and functionality coming so that we can actually get that coverage in Terraform. So we're doing everything we can, and we will continue to do what we can to add Terraform coverage, or the Azure Ram coverage, for new services and features and functionality. With that said, we do, there are specific scenarios that we will not have coverage, or typically will not have coverage in the Azure Ram Provider, and that's where the AzAPI Provider really shines. Before I get there, I want to start with kind of how easy it is to use the AzAPI Provider. So we've had feedback from customers saying, we don't want to use another provider, we don't know a whole lot about the AzAPI Provider, we just want the coverage in Azure Ram. So want to kind of dispel some myths about the AzAPI Provider. So the AzAPI Provider is actually very easy to use if you're already using the Azure Ram Provider. It shares the same authentication methods as the Azure Ram Provider. So if you're using service principals in the Azure Ram Provider, the same thing will apply to the AzAPI Provider. If you're using MSI or any other authentication method, it will almost invisibly be applied to the AzAPI Provider as well. So it makes it super easy to onboard and use. So what that means is the hurdle that you have to get over to actually use the AzAPI Provider is simply to add a couple of blocks to your configuration to add the AzAPI Provider as a required provider, and add the provider block itself. Other than that, most of the time, it should just magically work. A few things that you get in addition in the AzAPI Provider that we are experimenting with are things like defaults. So we give you the ability to add tags and location and some naming and stuff like that to the provider block, so that you don't have to worry about that or think about that in the individual resources. So if you have a set of tags that you want to apply to every single AzAPI resource in a configuration, you can add it to the provider block, and it will magically just show up in all of the resources themselves. All right, so let's take a quick look at an example of how you can actually start using the AzAPI Provider when you're already using the Azure Ram Provider. All right, so in this example, what I have here is just a simple configuration. You may have seen this before. If you've ever touched Terraform, I guarantee you've seen it, or for Azure anyway. All I'm doing is creating a resource group. I'm using the Azure Ram resource to create a single resource group. I have variables for the tags that I want to use for that resource group. And then I'm just creating some random names and creating 2 random names for resource groups. What we really want to look at here is the Terraform block and the provider block. So if I want to add another resource group using the AzAPI Provider, just as a simple example, even though it's already supported in Azure Ram, all I have to do here is add the AzAPI block, give it the source of Azure/AzAPI, and then add the provider block down here. Oops, yeah, provider, spell that right, AzAPI. Don't need to add the features block here, just the AzAPI block here. And what this is going to do is, since I'm using the Azure CLI to authenticate with the Azure Ram, it's just going to use that same authentication for AzAPI. And I have some environment variables set for the subscription that I want to use and the tenant that I'm using for Azure Ram. Those are just going to be reused for AzAPI. So if you're using the same variables or the same subscription and tenant, you don't have to do anything. It's just going to pick those things up and use them. So with that, I can actually come here and do a Terraform init, and that will actually pull down the Azure Ram and the AzAPI provider, and then I'm ready to go from there. So what I'll do in main here is just add the AzAPI resource here, and we're gonna call this AzAPI RG. Give it a type, resource group, and API version. So a couple of things that you may have noticed there is the AzAPI resource is a generic resource. Unlike Azure Ram, where you have an individual resource for all of the different types, for the AzAPI resource, we have a single resource here. We have some other ones that I'll talk about later, but you have a generic resource, and then you give it a type that you want to actually manage. And what that does is controls, we have a language server and extension for the VS Code, so it gives you some good syntax highlighting and things like that for this, so that it makes it easier for you to author these. So I'll give this a name, and what I'll do is just take the second random RG name here and give it that name. And then the other thing that's unique to the AzAPI provider is giving it the context where you want to create this resource. This resource, the resource group, is going to be created within a subscription. So what I'll do is select the subscription and the ID for that subscription to tell the AzAPI provider where I'm going to create this thing. From there, I need to give it a location, and for a location, I'm just going to call it West US. So that's all I need to do to actually configure the resource group using the AzAPI provider. You can see it's very similar to what you've done in the Azure Ram Provider, with a couple of other fields here that give you actually a lot of flexibility, as you might see if you start digging into this. So from there, if I save that file and do I'm just going to shortcut it and do a Terraform apply, even though I should do a plan. You'll see that this is going to go, would have done is just gone and created 2 resource groups, a resource group grown using Azure Ram and a resource group using the AzAPI provider. If you looked at the state for that, you would see that this resource is saved in the state. So if you make a change, like change this to another location, you would see, just like any other Terraform resource, it would detect that that's a change, and because you're changing the location of a resource group, you'd have to delete it and recreate it. So you'd get that feedback from Terraform saying, I need to delete this thing and recreate it. So these are full-fledged resources that you can use just like the Azure Ram resources. They just give you a bit more flexibility and give you the ability to manage literally anything in Azure and any API version in Azure. So hopefully you can kind of see the simplicity of adopting the AzAPI provider and the flexibility that it can give you to actually manage things in Azure. All right, let's jump back to our demo here. Next, let's talk about how you can actually use the AzAPI provider to manage those services that are not GA. Like I mentioned, there is a requirement to have GA coverage for Azure RM. But there are a number of circumstances when a service is private preview or public preview that you want to actually manage that using Terraform. And it's not implemented in Azure RM yet. It's not the only scenario, as you'll see, but it is a key scenario for the AzAPI provider. So like I mentioned while I was doing the demo, there is a language server and a VS Code extension for the AzAPI provider. Because the AzAPI provider is a simple layer or a very small abstraction over the Azure API, we don't want you to have to go read through REST documentation and all of that to figure out how to actually configure these things. So we've created the language server and VS Code extension to give you a really easy experience to actually manage these. So when you define the type that you're going to use in the AzAPI provider, when you go to the body of that property, you will have syntax highlighting and hints to what properties to use and what values and all of that. So you get that full fidelity of what properties I need to add to this thing without having to go dig into the low-level REST documentation. We also, because private preview features and functionality cannot have their APIs documented, we do give you the ability to actually skip that validation. So if you're given specific information about how to actually call an API that's not documented, and by not documented, it's just not yet documented, or the documentation is not accurate, and you have the ability to actually skip that and pass whatever information to Azure and let the Azure endpoint return any errors or confirmation to you. So it gives you the ability to actually manage, like I said, anything in Azure. So if you know that there's a new API version and that API version has new functionality, you can actually call that and skip validation and then call the API that way. This is especially useful in the private preview scenario, where most of the time when something's in private preview, it doesn't have public documentation for that API. All right, so let's take a look at a quick example here. All right, so let's look at a preview functionality here. So in this particular case, I want to manage the chaos service. The chaos service is, I think, in public preview at the time of this recording, but we don't have coverage for that yet in the Azure Ram Provider, and I think the documentation is somewhat limited on that as well. So there are a few prerequisites for the chaos service. I've set up a resource group that I'm going to configure here, create a virtual network, subnet, network interface, and then deploy a virtual machine to the subnet or the resource group as well. So all of this is going to seem very familiar to you. It's all using the Azure Ram Provider. And then one of the requirements for the chaos service is to have a user assigned identity or an identity. So I'm creating an identity using the Azure Ram Provider as well. You'll see over here that I'm using the AzAPI Provider and just passing in the AzAPI Provider block here. I could add some defaults here, like I mentioned. If I want the default tags here, I can add a block and add whatever tags I want here. So I can say author, oops, if I can type, author, and put my mark name in here. So now this set of tags, or this tag itself, will be applied to all of the AzAPI resources, which is a pretty convenient thing to use. So I go ahead and save that and move over to the other things that I have here, just for context. I have names, so I'm generating names, so I don't need to think about that. And then I have my configuration using the AzAPI Provider. So I'm configuring a few different things here in the chaos, or for the chaos service. I'm defining a target. I'm defining some capabilities for the chaos service, and then I'm defining an experiment. And that's kind of a full end-to-end configuration. So the target is going to use the Linux server that I'm configuring. I define the API version that I want to use here. I'm giving it a name in this particular case to configure the agent on the VM. I have to give it the Microsoft.agent name. And then I configure some properties, and this is where the user account or the user identity comes in. For that agent to run, you need to give it a managed identity, and then you pass in the information from that identity that I'm creating there as well. And then one of the things I'm doing for the chaos capabilities itself is to, I have a list of capabilities here in the variables. So these are all capabilities that will be enabled for that VM. And I am looping through those capabilities. So you'll have a whole bunch of different chaos capabilities resources here, and configuring those for that VM. And then the last thing I'm doing is setting the experiment here. And the experiment is setting, targeting that VM. So it's targeting the individual VM. So I define that VM as a target, and then define that target as where I'm going to apply this experiment. And then I actually define how often and kind of what the experiment is. So in this particular case, I'm just doing the simple time change experiment, and it's going to run every 10 minutes based on this. So one of the things that I mentioned and haven't shown you yet, but if I come in here and type name 4, you can see that it turns red underlined here. That's because I have defined this as the chaos experiment type here. That schema is actually published, and the language server picks that up and will tell you this name 4 thing. I don't know what this is. It doesn't apply to this chaos experiment. So I'm going to give you some heads up that that doesn't work. You can also get hints on the values here. So if I hit quotes here, you can see that from the schema, it'll tell you the specific values that are allowed here as well. So you get, like I mentioned, that full fidelity that you would expect from Terraform, even though this is a very small layer over the API. So if I save that, here I can come down and go to my shell, do a Terraform init. That will, like previously, it will get all of the providers pulled down and set up for me, the AzAPI Provider, the Random Provider, and the Azure Ram Provider, and do some quick syntax highlighting. And then if I do a Terraform apply here, that is, I will fix that real quickly in the provider. Sometimes when you get suggestions here, it adds the paren there. So if I fix that and come back and do my apply again, you'll see that this will go and actually stand up all of those prerequisites, the VM, and then actually deploy the chaos service itself. I will pause here for a second, and you'll see, like any other run of Terraform, you're gonna see it's gonna tell you what it needs to do to actually make the configuration happen. And then I will go ahead and apply that. And I'll jump back and let that run. It takes a minute or so, but you can see here that it's gonna create 27 different resources, and that's for a number of different reasons. You have some of those random names here, but I had that for each statement in there for the capabilities. So you'll be able to see in here there's a whole bunch of capabilities that are created kind of up at the top here, a whole bunch of capabilities. So it'll create a resource for every one of those capabilities. So I'll go ahead and say yes here, and that's going to go ahead and apply all of those things. One of the things that I'll point out here as well is I did add a dependency here on the capabilities because there is no implicit dependency in this resource pointing to the capabilities. These capabilities need to be enabled before the experiment is configured. So I did add a dependence on there to ensure that those capabilities are completed before the experiment is created. All right, so while that runs, we'll come back and look at the results of that after kind of moving on to the next section here. So let's jump back here and move on and see what else you can use the AzAPI provider for. So as you can see, not only can you actually, not as you can see, but not only can you manage new services with the AzAPI provider, but there are a lot of services. Kubernetes is a prime example, but there are a lot of services in Azure that iterate very quickly. So they add new features and functionality on a monthly basis or a couple of months, every couple of months. So they're really adding value very quickly, and the Azure Ram Provider can take some time to actually add support for those, especially if those features and functionality are released in preview first. So the AzAPI provider can give you the ability to actually manage those. So what's great about the AzAPI provider is we have this AzAPI update resource, and the update resource gives you the ability to not have to manage the entire Azure resource using AzAPI. You can actually, if you have an example, if you have the AKS provider already being managed using the Azure Ram Provider, you can use this update resource to just manage the new functionality, which is extremely powerful. And then, like you've already seen, you can manage any API. So if the AKS is, the Azure Ram Provider is using version 5 of the AKS API, and new functionality is released in version 5.1, you can actually target that with the update resource and manage that new functionality using the update resource. So let's jump back into our demo here and see if the previous example actually finished. It did, so that took a couple of minutes, like I mentioned. That ran and applied all of those resources. So if I were to go to the portal, I'd now actually see that I have the VM, the resource group, the chaos experiment, and everything all configured for me there. And also, if I do I'll expand the view here. If I do a TF plan here, you'll actually see that like any other Terraform configuration, because there have been no changes, this is going to come back and say no changes needed. So like I mentioned early on, you do get the full fidelity here of Terraform, unlike some of the other workarounds that are out there using ARM templates or the null resource or what have you. All right, so let's jump over to my next example here, adding new features. In this example, I have a Kubernetes cluster. Like I mentioned, they add a lot of new functionality on a pretty regular basis. I have a basic Kubernetes cluster. It's going to be added to a resource group. It's using Azure Ram for both of those. I want to add a new feature. So this has already been deployed to kind of save some time in this example, but I want to add a new feature that's not yet supported in Azure Ram, and it's adding a Node OS upgrade channel, so giving you the ability to actually automatically update the OS on the nodes themselves. You can see here that I'm using the update resource, and in the update resource I tell it what type I want to use, and I'm augmenting the Kubernetes cluster here. It's using a preview API, unlike the AKS Azure Ram resource. So I'm pointing it to a new API version here. And then I tell it what resource I want to augment. And this is just referencing the Azure Ram resource. And then I put only the properties in here that I want to augment. So the new properties that I want to augment to the Kubernetes cluster itself. So in this case, it is within the properties block, it is a auto upgrade profile and a Node OS upgrade channel setting to the security patch. You get the same fidelity here that you would for a resource itself. If I change the name of this property, it's not part of the schema, so it tells you that that's not a valid property. If I went to apply this, it would give me feedback and say, you can't do that because that is an invalid property. It should do the same with the values here as well if they're defined in the schema. So with that, let's save that real quick and do a Terraform apply here, and you'll see that it will very quickly add that functionality to the Kubernetes cluster using the AzAPI update resource. Give this a second here, I'll do a plan. I'll say yes, and I think this happens like within a few seconds. So once it gets through the initial information, I'll say yes. It's only going to add one thing here, and that one thing is the update for the update channel here. All right, so in this demo, what we're looking at here, we have a number of resources that are, a couple of resources here that are managed with the Azure Ram resource, our provider. We are creating a resource group, and we are deploying a Kubernetes cluster. There's some new functionality that has been added in a preview state to the Kubernetes cluster. Like I mentioned before, the Kubernetes team is at work adding new features and functionality on a pretty regular schedule. So this functionality is in preview, so is not available in the Azure Ram provider yet. So what we're gonna do here is use the AzAPI update resource to actually manage that new functionality and that new functionality alone. So as you can see here, we're using the update resource. We give it a type that we want to manage, and we want to actually augment the managed cluster, the Kubernetes managed cluster, and we're going to use a preview API here. So unlike the Azure Ram provider, we're managing a new API, and then from there all I need to do is point at the resource that I'm going to augment, and that is the ID. So we can grab that from the Azure Ram resource, the Kubernetes cluster. So you're going to augment that, and then you give it the only the additional functionality that you want to manage. In this particular case, it's going to manage the Node OS upgrade channel. So you want to set it up to update the OS for security patches, so that you don't have to think about it, and the nodes themselves will be updated on a regular basis. You notice here that I'm not putting all of the other properties for the managed cluster here. I'm not overwriting anything from the Azure Ram provider and resource itself. I'm just adding this new functionality. With that, if I do a plan and apply here, you would see that this resource gets applied and augments the managed cluster. So you'll end up with this functionality being added to the existing cluster. And if I do a plan after applying that, you would see that the cluster itself doesn't know about that property, so it doesn't tell you it needs to change it back to null or anything like that. Because the Azure Ram Provider has not implemented it, doesn't know about that property, it's not going to see any conflict there. So this resource will succeed and say no changes. And then this AzAPI resource will manage that single property itself. Due to timing here, we're kind of running long. I'm just going to kind of stop it there and kind of move on back to the last couple of demos that I have here. All right, so the next scenario is there are some very complicated scenarios that you just can't handle from or with Azure RAM. The AzAPI gives you the ability to manage those scenarios as well. We have the action resource that allows you to manage actions. So things like doing a start of a VM or kind of those not declarative or end state things. It's I want to reboot the machine or something along those lines. So it gives you the ability to do some of those actions, we have two different resources that are interesting. We have a data source that allows you to do a list. So if you want to get all of the VMs in a resource group or something like that, you can use the data source, or you can do deep gets and other things with that. So it gives you some real flexibility to add functionality to your configuration. And then you can feed that information back into the AzAPI resource or Azure RAM resources as needed. The resource, the action resource, will allow you to handle things other than put. So it will handle patches and posts. So some API calls require to be to use patches and posts. This gives you the ability to do that. And one of the other things to know about the action resource is the delete action is a no-op. So the create action will actually do the put, patch, post, and what have you. But when you remove this resource, it's going to be a no-op. It's not. There's no context, or there's no undo for these things, or there's no common undo for these things. So it's just a no-op, and it doesn't do anything on the delete. The other thing to know about not only the action resource, but all of the other AzAPI resources is you can export any property. So you're not limited to a set of properties that are returned by the Azure Ram resource. You can actually get anything that's returned from the API itself. You can actually return and use the information from that. So let's take a quick look at that, or a scenario that exemplifies that. So in this last scenario here, I will look at a scenario where I am managing, again, Kubernetes. I'm managing it with the Azure Ram Provider, so I'm managing the Kubernetes cluster. And I have a resource group for the Kubernetes cluster. But I'm also grabbing, putting together the resource group that contains the resources for Kubernetes, and by resources like the VMs and networks and stuff like that that are used by Kubernetes. There's a known pattern for the resource group that contains that. So I'm building that based on output from the Azure RAM resources themselves. And then I'll use the AzAPI update resource. So I'll use the data source and the, I'm sorry, not the update resource, the action resource. So I'll use the data source and the resource to get all of the VMs in that resource group. So I'm looking at the resource group. I give it the resource group of that resource group that contains the VM scale sets for that Kubernetes cluster. So I'll get those, return all of those VMs, and then I'll actually update the VMs and give it the user assigned identity for that. So right now the Azure or the Kubernetes API doesn't allow you to do this. So this gives you a way to actually manage the user assigned identity, or to to add a user-assigned identity to the VM instances in the VM scale set. So you can see that I get the VM scale sets, or the VM instances in a VM scale set. I'm taking the first one. You could do a loop here and do all of the Terraform HCL magic if you wanted to, but I know there's only one in the example that I have. So I'm getting that first one. And then I'm going to assign the user-assigned identity to that machine, that virtual machine scale set, or the instance of the virtual machine scale set, using the user-assigned identity that was created. In this particular case, I have the Kubernetes already configured here. And again, due to time, I'm not going to run this, but you can see that this would get the information, add the user-assigned identity, and then you can actually use that user-assigned identity to give those VMs access to whatever you need to give them access to. So it gives you some really good flexibility in what you can accomplish in Terraform with Azure. All right, from there, let's jump to the last scenario here. All of this great stuff that you get from AzAPI, we do recognize that most customers will want to move to the Azure Ram Provider from AzAPI at some point. So we do give you tooling that allows you to actually do that migration. Very creatively named. We have named it AzAPI to Azure RAM. So it does just what it says. It allows you to actually migrate those AzAPI resources to Azure RAM when Azure RAM actually supports that functionality. We have a plan and migrate mode in here. So the plan mode will tell you what resources can be migrated. And then when you do the migrate, it will migrate both the HCL and the state. So you won't be in a scenario where you need to manually manipulate the state or anything like that. This tool will take care of that for you. So it's a really powerful way of actually updating that configuration. We'll jump into the last demo here real quickly, and I will talk you through what this does. So in this particular case, I just have an endpoint policy here that's defined in the AzAPI resource. And it's defined in the AzAPI resource here. This actually exists in Azure RAM now. So if I want to migrate that, and I go to my fifth example here, I can do an and do a plan in here in this directory. And this tool will actually go and look at my configuration and see what can be migrated. So it knows the functionality that's in Azure RAM, and it can compare that to what you have configured in AzAPI, and then come back and tell you what, if any, resources it can migrate. So you have a few different options here. You can migrate everything that the tool recognizes, but we also give you the ability to target which resources you want to migrate. And we have documentation on the repo for that, on how to do that. But you essentially create a file that says, has the IDs of the resources that you want to migrate in there, and it will limit it to those. So you can see here that it recognizes that it can migrate the endpoint policy AzAPI resource, and we'll create this Azure RAM resource here. So if you're okay with that, you can do a AzAPI to Azure RAM migrate, and this will go through and do that migration. So like I mentioned, it's going to upgrade or update the HCL here, as well as the state itself. So if I do that migrate, this should happen pretty quickly here, and go through and update that information. A couple things to point out here, that this is the AzAPI resource here is using an AzAPI resource. This will work for the AzAPI update resource as well. So if you're adding a feature to an Azure RAM resource, this will recognize that there is an Azure RAM resource already, like in the example that we showed before, the Kubernetes cluster. It will recognize that that already exists, and this feature is now supported in that, so it'll actually migrate that over as well. So you're not limited to full resources. It will actually migrate the updates as well. So if we come back here, hopefully this worked. It did not. All right. So the demo guide's not with me, but the idea here is that it will actually do the update of the HCL. And you can see here it started to do that update and failed for some reason, but it will actually migrate that over. So it'll update the HCL, update the state, and you'll be good to go from there. All right. So jumping back and finishing up here, let's talk about some stuff that we have coming for some of these tools. Just a brief overview of some of the features and functionality that we have coming on the roadmap. From a verified modules perspective, we're going to continue to build up our library of modules. We are, like I mentioned, internal teams at Microsoft as well as the community are investing in that. We are coming up with some internal tooling to help streamline the process of onboarding verified modules. So if you have a repo that already has a good module in it and it wants to be migrated to the verified module, we're coming up with some tooling to streamline that process so it's not as manual as it is right now. And we're also doing some things like adding some variables to verified modules, so you can track where the module came from, any changes that were made to it, and all of that. And we're taking advantage of some an open source tool called Your that will add those variables. We are doing that in a way that you can turn it off. So if those variables are not valuable to you, you can opt out of that and not see any of those variables, or you can select the individual ones that you don't want to see. The export tool itself, we are doing some user experience improvements as well as some performance improvements. We want to make that as powerful as possible. We've got feedback that the performance is not great, but it still makes your life easier because you can kick it off and just kind of go on your regular day or regular business. But we have some approaches that we're looking at to actually improve that performance. The AzAPI Provider itself, one of the things that you're currently limited to with the AzAPI Provider is managing the Azure control plane. So anything that you can manage in ARM templates, you can manage in AzAPI. But there are scenarios that you can manage in the Azure Ram Provider that you can't manage in AzAPI, and that's data plane, Azure AD, and things like that that are exposed through the MS Graph. So we're looking at adding those as well, so you can manage key vault keys and secrets and those types of things. So we are working currently on the data plane and then looking at whether we can actually support MS Graph and a few other things. We're also looking at adding the ability to add some default naming conventions. So one of the important things with Terraform is to have company naming conventions, and adding the ability to actually have that automated would be a powerful feature. There are some limitations in some of the APIs that we're adding support for as well, or are looking to add support for, like URI filters and stuff like that. And lastly, we have a handful of installer packages, but we're looking at extending the installer packages for AzAPI just so it's easier to install and get going with. So, all right, with that, wanted to add a few links here that you can go check out and learn more about any of the content that we've talked about today, as well as catch us on Twitter and give us feedback on GitHub, and definitely do join our community. We want to hear from you, and we want to participate in the conversations. With that, I want to thank you all. I really enjoy sharing this information with you and hope you find it valuable. So thank you very much, and have a great rest of your conference.